Hey, welcome back. So, in our last explainer, we really laid the groundwork for process control. Today, we're going to take that next huge step. We're going to shift our whole way of thinking, away from just catching mistakes and toward preventing them from ever even happening.
And just so you know, this whole breakdown is based on the fantastic work of Mohammed Ajaluni. Now, if you remember from part 1, the big idea was simple, but really powerful. If you want to control the output of your process, you absolutely have to control the inputs.
Okay, but that brings up a whole new question, right? Once we've actually made something, how do we know if it's any good? How do we measure its quality? How do we know if we actually hit our target? That is the big question we're going to dig into today. So here's the game plan. We'll connect the dots from inputs to quality, and then we'll define what makes something critical to quality. After that, we'll look at two very different ways of thinking, the old school inspection approach versus the modern process control approach. Then we'll diagnose the two main reasons a process fails. And finally, we'll see what's next. First up, let's talk about getting from inputs to quality. The logic here is actually beautifully simple. Any little bit of variation in the things you put into your process, could be temperature, pressure, the raw materials, is going to create variation in the final product. It's just a basic cause and effect relationship you can't get away from. So, if we know our product is going to have some variation, what do we do about it? Well, we need a target to aim for. And that is where we define what is critical to quality, or CTQ for short. Seriously, just think of it as defining the bullseye for our process. Okay, so officially, a CTQ is any measurable attribute that tells you straight up if the product is good enough for your customer. Now, the two most important words there are measurable and customer. This isn't about what we think is important. It's all about what the customer values and what we can actually objectively measure with a number. And this can be just about anything, really. We could be talking about physical dimensions, the exact weight of a part, its hardness, how thick a liquid is, that's viscosity, the precise shade of a color, or even the pH level in a solution. All of these are solid, measurable CTQs. Now, this is where the idea really comes to life. Let's say our CTQ is the diameter of some part we're making. The target, the absolute bullseye, is 12 millimeters. But we have a tolerance, an acceptable range of plus or minus 2 millimeters. So what does that mean? It means anything between 10 and 14 millimeters is good to go. But if it falls outside that range, well, that's a defect. So how do we make sure only the good products actually get through? Well, the traditional way is what's called the inspection-based approach. I always think of this as a sentry, a guard, standing at the very end of the production line, checking every single part one by one and deciding pass or fail. But here's the massive flaw with that model. The sentry only catches the bad parts after all the time, money, and materials have already been spent making them. It is purely reactive. And the cost isn't just the part you have to throw away. It's the wasted labor, the lost machine time, the energy you burned, all of it for nothing. And maybe worst of all, the sentry has no idea why the defects are happening. It's an incredibly expensive solution that doesn't actually solve the root problem. And that brings us to a much, much smarter way of thinking about this, the process control approach. Instead of a sentry at the end of the line, I want you to imagine a coach who's watching the game while it's being played, making little adjustments in real time to make sure the team wins. And this lays out the difference perfectly. Inspection focuses on the finished products, and it happens after production. The goal? To detect defects. Process control flips that whole script. It focuses on the process itself, it happens during production, and the goal is to prevent defects from ever being made. It's a total shift from being reactive to being proactive. The power of this approach is just immense. By monitoring the process as it's happening, you can spot weird patterns or see if things are trending in the wrong direction or catch sudden shifts before they result in a bad product. This lets you jump in and take corrective action, basically saving the day before there's even a problem to begin with. But look, let's be realistic. Things can still go wrong. And when a product fails to meet its specs, it almost always boils down to one of two big reasons. Understanding this diagnosis is absolutely critical. The first reason is just excessive variation. Your process is all over the place. Think of a dart player whose throws are scattered all around the board. The average might be near the center, but the wild inconsistency means a lot of throws miss the mark entirely. On a graph, this looks like a wide, flat bell curve. The second reason is what we call a process shift. Now here, your process might actually be super consistent,
but it's consistently wrong. The average has drifted away from the target. This is like that same dart player, but now all their darts are landing in a tight little cluster way over on the side of the board. This looks like a nice narrow bell curve that's just shifted off center. So here is the most crucial point to get from all of this. Excessive variation and a process shift are two totally different problems, and you can't fix one with the solution for the other. It just won't work. A scattered, inconsistent process needs to be stabilized. An off-target but consistent process needs to be recalibrated. Getting the diagnosis right is everything.
Okay, this brings us to the final piece of our puzzle for today. We've figured out that preventing defects is the real goal, and we know the two main ways a process can go off the rails. So what's the coach's playbook for actually getting this done? It all comes back to this one single powerful idea. True quality management isn't about being the best inspector in the world. It's about building a process that is so good, so stable, that it doesn't make junk in the first place. The focus has to shift from detection to prevention. And that leaves us with one final and really important question. If we know the two ways a process can fail, either too much variation or a shift off target, what is the actual tool that lets our coach see these things happening in real time? What does that playbook even look like? Well, we're going to open it up in our next explainer. Thanks for joining me.